Hey everyone, and welcome back to 15-Minute Discourse. Today we're going to be diving deep into anti-gravity.
Ooh, exciting.
We've got a really interesting mix of sources for this one.
Lay it on me.
We've got scientific papers, historical reports on some government investigations,
Oh, wow.
even a news clipping from 1954.
Okay, so we're going way back.
Yeah, so we're going to see what people were thinking about anti-gravity back then. And then we're going to be looking at some theoretical physics too, things like string theory and negative energy. So we're asking the big question here. Is this all just science fiction, or could anti-gravity actually be a reality?
Yeah. Is this something that could actually happen?
What are scientists working on? What are some of the most promising areas of research? And what are some of the more outlandish ideas? So as always, we're going to keep things impartial, present the information to you so that you can come to your own conclusions.
Love that approach.
This is a topic that's really captured people's imaginations for decades.
Yeah. I mean, it is.
It's a really compelling idea, right?
It is. I mean, controlling gravity,
Yeah. Really makes you think about what's possible, what the implications would be.
Yeah.
And when you look back at the history of anti-gravity claims, you see this theme over and over again.
What's that?
Government secrecy.
Oh, really?
Like there's this idea that they know something we don't, and they're keeping it all hush-hush.
They're keeping it from us.
Exactly. Like that 1954 news clipping I mentioned. It's a perfect example of this.
Oh, really? Tell me more.
So this is a letter to the editor in the Binghamton Sun Bulletin.
Uh-huh.
And this guy, Donald Keyes, he wrote in, and he basically accused the government of using spaceflight as this big smokescreen to hide his secret anti-gravity program.
Wow. Even back then, they were thinking about this stuff.
Yeah, it's really fascinating
It is fascinating.
that this mistrust has been around for so long.
Yeah. So it's not just like a recent thing with the internet and all that?
No, this goes way back. And it's not just historical speculation either.
What do you mean?
I mean, even today, right? People claiming that the government's recovered alien technology, and they've got these secret programs working on reverse engineering it.
Right, right. Like Area 51, all that stuff?
Exactly.
Huh.
I mean, how many documentaries have we seen about Area 51?
Countless.
It's like a cultural phenomenon at this point.
It really is. So is there any truth to any of this?
Well, that's the thing, the AARO.
That's the Airborne Object Identification Program.
Yeah, they actually addressed these claims directly in their 2024 historical record report.
Oh, wow. So they're actually looking into this stuff.
Yeah, and they investigated these allegations pretty thoroughly. So did they find a government warehouse full of alien tech?
That's the question, isn't it?
What did they find?
Well, no, they didn't find any evidence to support those claims.
So no alien spaceships hidden in hangars?
Nope. The report concluded that most of those claims stemmed from people misidentifying classified programs, or just because they didn't have any firsthand knowledge.
So basically a lot of hearsay and speculation.
Exactly. So they concluded that there was no evidence to support the idea that the government is hiding alien technology.
That's a pretty significant takeaway. I mean, after all these years of speculation,
Right.
an official government report debunks these persistent rumors.
It's pretty huge.
So does that mean that there are no secret government programs looking into anti-gravity at all?
Well, not necessarily. The IRO did find that a lot of these modern allegations, they could be traced back to individuals who were connected to this canceled DIA program called the Advanced Aerospace Weapons System Applications. And this program focused on exploring fringe science.
So they were looking into some pretty out there stuff.
Yeah, and while it didn't produce the results they were hoping for, it does show that the government has at least investigated these unconventional ideas.
So they're willing to at least look into it, which is interesting in itself.
Definitely.
The report also goes into the history of UAP investigations, projects like Cyan Grudge and Bluey Book,
Oh, yeah, I've heard of those.
which I think gives us some really important context for understanding how the government has approached these unexplained phenomena over the years.
That makes sense.
But let's move away from government conspiracies for a bit and talk about what's often misconstrued as anti-gravity. I feel like I've seen so many videos online of people claiming to have invented anti-gravity devices.
Oh, yeah, me too.
And I'm always so skeptical.
Yeah, there's a good reason for that skepticism. There are a lot of misunderstandings about what anti-gravity actually is.
And how it would even work.
Right.
And the NASA paper responding to mechanical anti-gravity does a good job of breaking down some of those common misconceptions.
So what are we talking about here? What are these so-called anti-gravity devices?
Well, there are two main categories that often cause confusion: oscillation thrusters and gyroscopic devices. And these devices can appear to defy gravity,
Uh-huh.
but they're actually working within the laws of physics.
Okay, so walk me through this. How do they work, and why aren't they actually anti-gravity?
Okay, so oscillation thrusters, for example, they rely on differential friction, and it creates the illusion of thrust, but it's not actually generating a force that opposes gravity.
So it's like tricking the eye into thinking something is defying gravity when it's really not.
Exactly. And then gyroscopic devices, they're often misinterpreted because of their unique behavior. They exhibit torques.
Which are rotational forces. And those torques can get mistaken for linear forces.
So again, it looks like they're defying gravity,
Right.
but they're actually just demonstrating the principles of angular momentum. How do you even begin to address these claims, especially when people are so invested in their inventions?
Well, that's one of the challenges that the NASA paper highlights. They emphasize the importance of rigorous scientific methods
Right.
and the need for solid evidence to support any claims of anti-gravity.
So it's about approaching these claims with a healthy dose of skepticism and demanding verifiable proof.
100%. But here's the real question.
Yeah, what's that?
Is anti-gravity even possible within the laws of physics as we currently understand them?
That's the big one, isn't it? I mean, is it even theoretically possible to create a device that generates anti-gravity?
Right.
So what does science say?
Well, there are some theoretical explorations that suggest it might be possible. And one of the most exciting areas of research is unified field theories.
Okay, so unified field theories. These are attempts to bring gravity together with other fundamental forces like electromagnetism, like a grand unified theory of everything.
That's the idea.
That's a big one.
It is. And some of the leading contenders in this field are string theory and loop quantum gravity. And both of these theories, they have the potential to revolutionize our understanding of gravity, but they also come with their own set of challenges.
Like, what kind of challenges are we talking about here?
Well, one of the biggest challenges is experimental verification.
Right, because these theories are dealing with realms of physics that are so tiny or so energetic that we can't even observe them directly.
It's really hard to study them.
So it's hard to say for sure if their predictions are accurate. If they are accurate, what could that mean for anti-gravity?
Could it actually be possible? Well, string theory.
Yeah.
It suggests the existence of extra dimensions. And loop quantum gravity proposes that gravity behaves differently at very high energies. And if these ideas are correct,
Yeah.
they could open up entirely new possibilities for manipulating gravity
Wow.
in ways that we can't even imagine yet.
That's incredible. Unlocking the secrets of the universe to potentially control gravity. That's definitely venturing into sci-fi territory.
It is, but it's important to remember that these are still theoretical frameworks.
Right.
We're a long way from being able to test these ideas in a practical way. And that brings us to another fascinating concept that's connected to anti-gravity.
Okay, what's that?
Negative energy.
Negative energy.
Yeah.
That sounds like something straight out of a superhero comic book.
It does, doesn't it?
Yeah.
But it's actually a legitimate concept in physics. General relativity, which is Einstein's theory of gravity.
Right.
It allows for the existence of negative energy.
Okay.
And theoretically, it could be used to warp space-time in such a way as to create repulsive gravity.
So instead of pulling things together,
Right.
it would push them apart.
Exactly.
I'm starting to see where the anti-gravity connection comes in.
Right.
So one way to potentially achieve anti-gravity with negative energy would be to create a spherical shell of it around an object.
Like a negative energy bubble.
Yeah, but here's the catch. The amount of negative energy needed for this would be astronomical, beyond anything we can currently comprehend.
Right.
So negative energy is real,
Yes.
but harnessing enough of it for anti-gravity is still a long way off. Are there any examples of negative energy that we can look to understand how this might work?
Well, there's one phenomenon that demonstrates negative energy in action, although on a very small scale.
Okay.
It's called the Casimir Effect.
The Casimir Effect. Fill me in. What is that?
All right, so imagine two perfectly smooth Metal plates placed very close together in a vacuum. Now, even a vacuum is teeming with virtual particles that pop in and out of existence constantly.
So these particles aren't really there.
They're there in a sense.
Okay.
They have measurable effects, but they exist in this weird quantum realm where they're constantly fluctuating in and out of existence.
So they're kind of there, but not really.
It's complicated, but because of the limited space between those plates, only certain wavelengths of virtual particles can exist there. Outside the plates, there's a wider range of wavelengths.
So there's like an imbalance between the inside and outside of the plates.
Exactly. And this imbalance creates a pressure, pushes the plates together. And that pressure is a manifestation of negative energy.
So even though the Casimir effect demonstrates negative energy, the force it produces is just too weak to have any practical applications for anti-gravity.
Yeah.
At least for now.
At least for now.
But it's still a fascinating phenomena.
It is.
And it gives us a glimpse into the potential of negative energy.
It does.
There's also research into something called quantum anti-gravity, which focuses on manipulating quantum forces to potentially create anti-gravity effects. But it's still very much in its early stages.
We're a long way off.
So we've got these tantalizing possibilities, but the technology just isn't there yet.
Right.
What about superconductors? Have they shown any promise in relation to anti-gravity?
That's a great question. And it's one that sparked quite a bit of controversy over the years. Research into superconductors and their potential gravitational anomalies goes back decades. But it really heated up in the 1990s, the work of Eugene Podkletnov.
Podkletnov. Wasn't he the one who claimed to have observed a gravity shielding effect above a spinning superconducting disk?
That's the one.
Okay, so what was his experiment?
His experiment involved a spinning superconducting disk cooled to very low temperatures and subjected to a magnetic field. And he claimed that objects placed above the disk experienced a slight decrease in weight.
So like a mini anti-gravity field.
Essentially.
Wow.
But Podkletnov's findings were met with a lot of skepticism from the scientific community.
Why was that?
Well, for one thing, no one else has been able to replicate his results independently.
Oh.
And there were also concerns about the experimental setup and potential sources of error that might have skewed the findings.
So it's possible that what he observed wasn't actually a gravity shielding effect,
Right.
but something else entirely.
Exactly.
But despite the controversy, Podkletnov's research did spark a wave of interest in the connection between superconductors and gravity.
It did.
So other researchers started investigating.
NASA even got involved.
Wow, okay.
They conducted experiments to try and replicate Podkletnov's findings, but their initial attempts failed to observe the gravity shielding effect. However, they did later attribute a weak gravity increase they observed to an instrumentation artifact.
So they didn't confirm Podkletnov's specific findings.
Right.
But their research did suggest that there might be something unusual happening with superconductors and gravity.
Yeah.
Okay, so we're back in the realm of something weird is going on, but we don't know what.
Exactly.
And this is where the work of Martin Kashmir comes into play. He's another researcher who's been looking into superconductors and gravity. And what did he find?
Well, his experiments involved spinning superconducting rings and measuring their acceleration. And he observed unexplained acceleration signals that didn't match any existing theoretical predictions.
So more anomalies, but unlike Podkletnov's findings, these experiments have been replicated by other researchers.
They have, yes.
Which lends them more credibility.
Exactly. What's interesting is that they didn't match previous theoretical predictions. So
Right.
there's something unique happening here.
Right.
But we need more research to figure out exactly what's going on.
So it's a mystery, still waiting to be solved.
Exactly.
That's what makes this field so exciting.
It does.
There's so much we don't know, and the possibilities are truly mind-boggling.
Absolutely.
All right, so before we jump into the mysteries surrounding superconductors, I want to circle back to something we touched on earlier.
Okay.
That idea of negative energy and its potential role in creating anti-gravity.
Right.
Now, negative energy still feels like a concept straight out of science fiction, but we know it's a real thing,
Right.
at least in the realm of quantum physics.
Yes.
And we talked about how even though we can't create massive amounts of negative energy for practical anti-gravity applications right now, there is this fascinating phenomenon where negative energy plays a crucial role.
Oh, tell me more.
Black holes. those cosmic enigmas that warp space-time and capture even light within their gravitational grasp.
So powerful.
And what's really fascinating about it is how they warp space-time to such an extreme degree that they create this region known as the event horizon. And within the event horizon, something truly bizarre happens. The fabric of space-time itself becomes so distorted that it essentially flips holes of space and time.
Wait, hold on.
Yeah.
So inside a black hole, space becomes time. Time becomes space.
It's a concept that's so difficult to grasp.
Right, because it defies everything we know.
It defies our everyday experience of reality. But the mathematics of general relativity tell us that it's what happens.
Wow, so that's what the math says.
Yeah, it's pretty wild.
So how does this tie back to negative energy and possibility of anti-gravity?
Well, the warping of space-time
Okay.
near a black hole is so extreme
Uh-huh.
that it creates a region of intense negative energy density. And some theoretical physicists believe that this negative energy could potentially be harnessed for anti-gravity propulsion.
So we're talking about tapping into the power of a black hole, create anti-gravity.
Right. I mean, are we venturing into science fiction here?
It's an incredibly ambitious idea, to say the least.
Yeah.
It really pushes the boundaries of what we currently understand about physics and engineering. But there are some intriguing concepts out there that explore this possibility, the idea of creating a wormhole.
Those theoretical tunnels through space-time
Yeah.
that could connect distant points in the universe.
Right.
Is that what we're talking about here?
Yeah, and some physicists believe that it might be possible to create a wormhole by manipulating the negative energy around a black hole. The idea is to use the black hole's immense gravity to warp space-time and create a shortcut through the fabric of the cosmos.
Okay, so you're saying we could potentially use a black hole as a cosmic shortcut to travel vast distances.
It's a very sci-fi idea.
It's starting to sound a bit like Star Trek.
It is something that's been explored in science fiction, but it is grounded in theoretical physics. The challenge, of course, is that creating a stable wormhole would require an unimaginable amount of energy and control over gravity, far beyond anything we're capable of right now.
So it sounds like we're still in the realm of speculation,
We are.
but it's a fascinating concept nonetheless.
Oh, absolutely fascinating.
So we've got black holes, wormholes, negative energy,
Right.
all swirling together in this mind-bending mix of theoretical physics.
It really is mind-bending.
It is a lot to take in, and it highlights the fact that we're still just scratching the surface, understanding gravity and its potential.
Yeah, we've got a long way to go. We've talked about the potential of negative energy,
Right.
but there are other avenues of research that hold promise as well.
Like those superconducting materials that we were discussing earlier.
Yes.
And the strange anomalies they exhibit.
Yeah, those are really interesting.
We were talking about the research with Podklitnoff and Tajmar, where they observed those unexplained weight changes and acceleration signals in spinning superconducting systems.
Right. Some really strange stuff going on there.
Right.
And even though those findings weren't conclusive,
Yeah.
they were incredibly intriguing. They really raised the question of whether superconductors might have some intrinsic property
Okay.
that allows them to interact with gravity in unusual ways.
So it's possible that superconductivity, a state where electrical resistance vanishes, could somehow be linked to gravitational effects.
It's a possibility. Could superconductors be the key to unlocking anti-gravity?
That would be pretty remarkable.
It would be. But it's important to remember that we're still in the realm of speculation.
Right.
There's no concrete evidence to support this claim yet.
But the research continues.
It does.
And scientists are still trying to unlock the secrets of superconductors and their potential connection to gravity.
Absolutely. And who knows what they might discover.
Right.
We've explored some fascinating possibilities with superconductors, negative energy,
Right.
and even the potential of harnessing the power of black holes. But there's another intriguing area of research that could have major implications for our understanding of gravity, perhaps even anti-gravity.
Or what's that?
Unified field theories, those attempts to bring together all the fundamental forces of nature into a single coherent framework. And as we discussed earlier, some of the leading candidates in this arena are string theory and loop quantum gravity. And these theories suggest gravity might behave differently at extremely high energies or in the presence of extra dimensions.
So we might need to completely rethink our current understanding of gravity, if these theories turn out to be correct.
Exactly. That's what makes this field so exciting. There's so much we still don't know.
It's a really exciting field.
And the potential for breakthroughs is immense.
I'm ready for those breakthroughs.
Me too.
The implications of anti-gravity are just mind-blowing.
They are. But in the meantime, let's talk about something a bit more down to earth.
Okay.
The practical implications of anti-gravity, if we could ever harness it.
Okay, so let's imagine for a moment that we could overcome the immense technological hurdles
Right.
and actually develop anti-gravity technology.
Yeah.
What would that mean for humanity?
Oh, wow, that would change everything.
It would revolutionize transportation, for starters.
Right. We could have vehicles that could effortlessly lift off the ground and soar through the air.
No need for roads or runways anymore.
Exactly. We could say goodbye to traffic jams and airport delays.
It'd be amazing.
And space travel would become infinitely easier
Right.
and more efficient.
Yeah, we could send spacecraft to distant planets
Yes.
and stars without the need for massive rocket and the massive amounts of fuel they require.
Yeah, that'd be incredible.
It wouldn't just be transportation, they'd be transformed.
What else would change?
Energy production would also be revolutionized.
Okay.
We could harness the power of gravity to generate clean and sustainable energy. The possibilities extend far beyond transportation and energy. We could build towering structures that defy gravity, create new materials with incredible properties, and even develop medical treatment based on manipulating gravity.
It sounds like we'd be entering a whole new era.
Yeah, it would be a truly transformative event.
But with such power comes great responsibility. We'd need to carefully consider the ethical implications and potential risks of this technology.
Like, what kind of risks are we talking about?
Well, for one thing, if anti-gravity technology fell into the wrong hands, it could be used for devastating purposes.
Right.
Imagine weapons that could nullify gravity, causing widespread destruction and chaos.
That's a sobering thought.
It is. It's easy to get caught up in the exciting possibilities and forget about the potential downsides.
Yeah, it's important to think about those things.
It is. There's also the potential for economic disruption.
Oh, in what way?
Well, entire industries could be rendered obsolete
Right.
if we no longer needed things like cars.
Or even rockets.
Right. The whole economic landscape could shift dramatically.
It really could.
And there are social implications to consider as well. How would our society adapt to a world where gravity is no longer a constant force?
Right. What would it mean for our understanding of the universe and our place within it?
Those are all important questions that we'd need to grapple with if anti-gravity technology ever becomes a reality.
Yeah, it would challenge our understanding of the world and force us to redefine our relationship with the universe.
It's a lot to think about.
It is.
But for now, these remain hypothetical challenges, as we're still far from achieving practical anti-gravity.
Right.
It's a journey of exploration and discovery,
It is.
and we're still in the early stages.
We are. But the journey is just as important as the destination.
That's a good point.
And the pursuit of anti-gravity has already led to incredible discoveries.
Right. And advancements in our understanding of the universe.
Yeah, it really makes you appreciate the power of human curiosity and our drive to push the boundaries of what we know.
Absolutely.
Yeah.
It makes you wonder what the future holds.
It does.
Maybe one day we'll look back on our current understanding of gravity and laugh at how naive we were.
Yeah, that's possible.
But for now,
Yeah.
the mystery continues.
Now it's time to venture into the more speculative side of anti-gravity. Claims of government cover-ups, whispers of recovered alien technology, and those persistent rumors about secret projects happening in places like Area 51.
It's the stuff of legends.
It's the side of anti-gravity that really captures the imagination. That idea that somewhere out there, maybe in a hidden government lab, technology exists that could defy gravity as we know it.
I mean, wouldn't that be amazing?
It's definitely a thought that sends chills down your spine.
It does.
And it's hard to ignore those stories, especially when you have cases like the Roswell incident. It's
Yeah.
become almost synonymous with government secrecy and the idea of a hidden truth about alien technology.
Roswell is the classic example, isn't it?
Yeah.
The story of a crashed object in the New Mexican desert back in 1947. Initially identified as a weather balloon by the military, but later reclassified as a surveillance balloon from a top-secret project called Project Mogul.
It already sounds like something out of a conspiracy thriller, but those shifting explanations and the fact that it was a classified program, it fueled so much speculation that the government was covering up something much bigger, like a crashed alien spacecraft.
Exactly. And of course,
Yeah.
you have those who claim to have seen debris that didn't look like anything earthly,
Right.
and stories of alien bodies recovered from the crash site.
Yeah.
It became a breeding ground for conspiracy theories about the government hiding alien technology.
And where better to hide such a groundbreaking discovery
What?
than Area 51, the highly classified military base in Nevada?
Yeah.
It's almost become a mythical place in pop culture, synonymous with government secrets and hidden alien technology.
An icon of the unknown.
Yeah.
And it's interesting that the AARO,
Right.
in their 2024 historical record report, specifically investigated the claims surrounding Roswell and Area 51, looking for evidence to support those claims of recovered alien technology.
So after all that, did they find anything to support those claims?
That is the question, isn't it?
Was there any evidence of a secret stash of alien tech hidden away in a government bunker?
Well, no, they didn't.
Really?
The report concluded, after extensive investigation and analysis, that there's no evidence to support the claims of recovered alien technology,
So nothing.
whether at Roswell or any other alleged crash site.
So the government is sticking to their story,
It seems like it.
that it was a weather balloon or a surveillance balloon, case closed. But I imagine that's not going to stop the conspiracy theorists from believing that there's something more to the story.
Of course not. There will always be those who believe in a deeper truth,
Right.
a hidden reality that the government is trying to keep from the public.
Yeah, it's part of the allure of these stories.
It is.
The unknown, the possibility that we're not alone in the universe,
Right.
and that governments are in possession of technologies far beyond our imagination.
It's exciting to think about. But even if we set aside the alien theories for a moment, doesn't it seem likely that governments around the world have at least explored the possibility of anti-gravity technology through their own research?
I mean, that's certainly a possibility. We've already talked about the canceled DIA program, the Advanced Aerospace Weapons System Applications program, which looked into some pretty fringe science.
It did.
That was the program that delved into things like manipulating space-time, using concepts from general relativity.
They were exploring some very ambitious, almost science fiction sounding concepts, wormholes and warp drives, as potential ways to achieve anti-gravity.
It's fascinating that even though the program didn't lead to any breakthroughs in anti-gravity, it does show that the government is open to exploring these seemingly impossible ideas.
It does highlight there's likely a lot of research going on behind closed doors that we're not privy to. And it's that secrecy that fuels so much of the speculation.
Yeah, it's like the old saying,
What's that?
if a tree falls in the forest and no one is around to hear it, did it make a sound?
Right.
If classified research is happening in a secret lab
Yeah.
and the public is unaware, does it even exist? And that lack of transparency, I think, is what keeps those conspiracy theories alive.
Yeah, I think you're right. That's part of the appeal, isn't it? The mystery, the unknown. But it's important to remember that classified research doesn't automatically equate to alien technology.
Right.
Or a massive government cover-up. It could simply be that the research is sensitive for national security reasons,
Right.
or that it's at such an early stage that they
Yeah.
don't want to make premature announcements.
Okay, so let's get down to the big question.
Okay.
Is there any real chance, based on what we know, that anti-gravity technology exists somewhere out there, hidden away in a secret government facility?
It's impossible to say for sure. It's a question that has captivated people for decades.
It has.
But based on the available evidence and what we understand about the laws of physics, it seems highly unlikely.
So no flying cars or interstellar spaceships just yet.
Not based on anything we've seen. But that doesn't mean we should stop exploring the possibilities.
Right.
The pursuit of knowledge is what drives scientific progress.
Exactly.
And who knows what amazing discoveries await us in the future.
It's a journey of exploration.
It is.
And the possibilities are endless.
They are.
Even if we never achieve true anti-gravity.
Right.
The pursuit of that goal might lead us to breakthroughs we can't even imagine right now.
Yeah, that's the beauty of science. We never know where our curiosity will lead us. And sometimes the journey is just as fascinating.
It's been a mind-bending journey for us today,
It really has.
exploring the world of anti-gravity, from the hard science to the fringe theories, and the enduring mystery surrounding it all.
It's so fascinating.
We hope you've enjoyed this deep dive into the world of the unknown.
We hope you did.
And if you're as fascinated by the mysteries of the universe as we are,
We hope so.
be sure to subscribe to 15-Minute Discourse.
Yeah, hit that subscribe button.
for more deep dives into the most intriguing and thought-provoking topics out there.
We cover all sorts of interesting stuff,
We're always exploring the boundaries of what we know,
always pushing the limits.
and we can't wait to share those discoveries with you.
We'll see you next time.
So until next time, keep looking up, keep questioning, and never stop exploring the unknown.